Chapter 11. Symmetry. Symmetry is the right proportion between the parts of the body or any whole object. An object being divided by a point or a line or plane or radiating lines or planes into two or more parts exactly similar in size and shape and in position relatively to the dividing point, line or plane. Symmetry is an important geometrical concept in our daily life. In nature we find symmetry in flowers, leaves, animals, etc. Some examples of symmetry in nature are butterflies, arrangements of petals in flowers, beehives, trees, etc. Symmetry is also found in man-made structures, monuments like Taj Mahal, Qutub Minar, India Gate, Gateway of India, etc. Line axis of symmetry. A line or axis which divides the objects into two identical halves is called the line axis of symmetry. A figure or a picture which can be folded so that one of its two parts thus created will coincide with other half or it will completely cover the other half, then the figure or picture is symmetrical along the line of symmetry. Example: line of symmetry. Line of symmetry for regular polygons. Polygons are closed figures made up of line segments. Regular polygons are polygons having all sides and all angles equal. Example: A. Equilateral triangle. An equilateral triangle is a regular polygon since its all sides and angles are equal. In this case, there are three lines of symmetry. B. Square. A square is a regular polygon since its all sides and all angles are equal. In this case, there are four lines of symmetry. C. Regular pentagon. A pentagon having all five sides and all five angles equal. In this case, there are five lines of symmetry. Similarly, a regular hexagon have 6 lines of symmetry, regular heptagon have 7 lines of symmetry, regular octagon have 8 lines of symmetry, regular nonagon have 9 lines of symmetry and decagon have 10 lines of symmetry. Therefore, we can say that a regular polygon has a many lines of symmetry as the number of sides. Point symmetry. Consider a quadrilateral as shown in figure. It has no line of symmetry, so we can call it as asymmetrical figure. Draw both the diagonals and mark the point of intersection as O. Take a cardboard cutout of the same quadrilateral. Pin the cardboard cutout on a drawing board by drawing pins. Now rotate this by 360 degrees. You will observe that it looks just the same as before. Therefore, we can say that a quadrilateral has a point of symmetry around point O. This is called point symmetry. Rotational symmetry. Turning of a figure about a fixed point is defined as rotation. Rotation can be clockwise or anti-clockwise. When a figure is rotated about a fixed point, every point on the figure rotates through the same angle relative to fixed point. The fixed point about which rotation takes place is called the center of rotation. All figures when rotated through 360 degrees come back to their original position. We can understand the concept of rotation with the help of diagram. When a figure is rotated through an angle greater than 180 degrees and the figure looks the same, it is said half rotational symmetry. The number of times figure fits into itself in one complete rotation is called the order of symmetry. If a figure looks the same after a rotation through the angle x, when x greater than 180 degrees, then 360 degree upon x gives the rotational order of the figure. The rotational order of parallelogram is 360 degrees upon 180 degrees is equal to 2. Rotational symmetry of order 2, 3, 4. A rotational symmetry of order 1, that is if it looks the same after one complete rotation of 360 degrees, is considered insignificant. Example, the figure of T. The figure T got no rotational symmetry. The rotational symmetry of order 1 means no rotational symmetry, that is we cannot rotate it. The figure N and a parallelogram has to rotational symmetry, that is it's come back to its original position after 2 rotations. Now take an equilateral triangle ABC. Original position 120 degrees turn, 240 degrees turn, 360 degrees turn. After 3 rotations, the equilateral triangle ABC come back to its original position. So the symmetry order is 3. Rotational symmetry is equal to 3. Equilateral triangle. Now let us take a square ABCD. Original position 90 degrees turn, 180 degrees turn, 270 degrees turn, 360 degrees turn. The square ABCD comes back to its original position after 4 turns. So the order of symmetry is 4. There is a definite relation between line segment and rotational symmetry in some figures. Let us study the same by some examples. Rotational symmetry is equal to 4. Square. As earlier discussed, rotational symmetry of order 1 is not considered. Isosceles triangle. One axis of symmetry, so no rotational symmetry. The figure H. 2 axis of symmetry, so order of rotational symmetry is 2. Equilateral triangle. 3 axis of symmetry, so order of rotational symmetry is 3. Square. 4 axis of symmetry, so order of rotational symmetry is 4.